Now for these questions, we need to make fraction bonds to 1. So first, 1/5 plus what is equal to 1 whole? Well, let's show 1/5 in our fraction bar. What do we need to add so that our whole fraction bar is coloured in? Well, if we colour in the rest of our fraction bar in yellow, we can see that 4/5, so 4 parts out of 5, are now coloured in yellow. So 1/5 plus 4/5 is 1 whole. Because 1/5 of our fraction bar is blue, 4/5 is yellow, and that means that the whole fraction bar is now coloured in. Remember, 1 whole is the same as 5/5. Here, because we've got 5 parts out of 5 coloured in, either blue or yellow, we've got 1 whole fraction bar that's been coloured in. So now, 5/8 plus what is equal to 1 whole? Well, we can show 5/8 in blue, and then if we colour the rest in yellow, we can see that 3/8 or 3 parts out of 8 of our fraction bar is yellow. So 5/8 plus 3/8 is equal to 1 whole, because remember, 1 whole is the same as 8/8. In this fraction bar, we've got 8 pieces, and all of those pieces are coloured in, so we've got 1 whole fraction bar coloured in. You'll also spot 1 plus 4 is 5, and 5 plus 3 is 8. That's because if you add 1/5 and 4/5, you get 5/5, but that's the same as 1. And if you add 5/8 and 3/8, you get 8/8, and that's also the same as 1. So when the numerator and denominator are the same, you have 1 whole. So 4/7 plus what is equal to 1? Well, we can show 4/7 in blue, and then we can see that to colour in our whole fraction bar, we need to colour in another 3/7. 2/3 plus what is 1? Well, if we show 2/3, we need to colour in 1 more third to make 1 whole coloured in. And again, notice 4/7 plus 3/7 is 7/7, and 2/3 plus 1/3 is 3/3. If you have a fraction where the numerator and the denominator are the same, you always have 1 whole. Now let's count up in halves, thirds and quarters. So there's our half fraction bar, but let's count beyond 1. So if we put 1, 2, 3, 4 half fraction bars together, we can practice counting in halves. So that's 1/2. Now we have 2 halves, which we can write as 2 over 2. And because we have both halves of this fraction bar shaded, we can say that we have 1 whole fraction bar shaded. Now, if we keep going, we now have 3 halves shaded, so we can write that as 3 over 2. This is called an improper fraction because we have a larger numerator than denominator, but it still makes sense because each part is split into 2 or split into half, and we have 3 of those halves. Now we can also write this as a mixed number. That's 1.5, because we have 1 whole fraction bar shaded and half of another one shaded as well. Now if we keep going, here we've got 4 halves, so that's 4 over 2. And we have 2 whole fraction bars shaded. Now notice 4 divided by 2 is 2. But let's keep going. We'll come back to that in a moment. So now we have 1, 2, 3, 4, 5 halves, so that's 5 over 2, as an improper fraction, but as a mixed number, that's 2.5, because you can see we have 2 whole fraction bars shaded and 1/2 of another one. Now notice 5 divided by 2 is 2 remainder 1, so you can spot the pattern. Also notice that if you multiply the whole number of the mixed number by the denominator, 2 times 2 is 4, but then if you add the numerator, so 2 times 2 is 4, plus 1, you get 5, which is the numerator of the improper fraction. Now if we add another half, we have 6 halves shaded, and that's the same as having 3 wholes shaded, because 6 divided by 2 is 3, and we can see that we have 3 whole fraction bars shaded. Now we have 7 halves, which is 3.5, and if we keep going, we now have 8 halves shaded, which is the same as having 4 whole fraction bars shaded, because 8 divided by 2 is 4. So we're probably spotting some patterns here, but now let's practice counting up in thirds. So we need our thirds fraction bar, and let's again put 4 fraction bars next to each other. So we have 1/3, 2/3, and if we add another third, we have 3/3. Now having 3/3 is the same as having 1 whole fraction bar shaded. So if the numerator and the denominator are the same, you always have 1 whole. But we can keep going. Now we have 4/3, and as a mixed number, that's 1 and 1/3. Notice that 4 divided by 3 is 1 remainder 1. If we keep going, we now have 5/3, which is 1 and 2/3, because 5 divided by 3 is 1 remainder 2. Or, to change a mixed number to an improper fraction, here's what we can do. We can multiply the whole number by the denominator and then add the numerator. So 1 times 3 is 3, plus 2 is 5, and that's the numerator of our improper fraction. Now we have 6/3, and we can see that we have 2 whole fraction bars shaded, and that makes sense because 6 divided by 3 is 2. Now 7/3, or 2 1/3, 8/3, or 2 2/3, and 9/3 is the same as 3 wholes, because 9 divided by 3 is 3, and you can see that we now have 3 whole fraction bars shaded. If we keep going, we have 10/3, which is 3 1/3. Again, spot 10 divided by 3 is 3 remainder 1, so that's 3 1/3. The denominators are always the same. Now 11/3 is 3 2/3, and that makes sense because if we're changing the mixed number to an improper fraction, 3 times 3 is 9, plus 2 is 11, so 11 is our numerator of the improper fraction. And if we add another third, we have 12/3 altogether, so again we have 4 whole fraction bars shaded, because 12 divided by 3 is 4. So now let's count up in quarters. We need our quarter fraction bar, and again let's put 4 of them next to each other. We have 1/4, 2/4, which we can see is the same as 1/2, 3/4, and then 4/4 is the same as 1, because 4 divided by 4 is 1, and if we have the same number in the numerator and the denominator, we always have 1 whole, because our whole fraction bar's been split into 4, but because we've got all 4 of those pieces shaded, we've got 1 whole fraction bar shaded. But we can keep going. Now we have 5/4, which is the same as 1 1/4. Then 6/4, or 1 2/4. 7/4 is the same as 1 3/4. So remember, 7/4 is our improper fraction, and 1 3/4 is a mixed number. But they're both different ways of showing the same thing, different ways of showing what we have here. Now, if we keep going, we have 8/4, which is the same as 2. And notice 8 divided by 4 is 2. Now 9 quarters, so as a mixed number, that's 2 and 1 quarter, because 9 divided by 4 is 2 remainder 1. Or, going from the mixed number to the improper fraction, 2 times 4 is 8, plus 1 is 9. So 9 is the numerator of our improper fraction, and the denominator stays the same. So now 10 quarters, or 2 and 2 quarters, 11 quarters, or 2 and 3 quarters, 12 quarters, or 3, 13 quarters, or 3 and 1 quarter, 14 quarters, or 3 and 2 quarters, 15 quarters, or 3 and 3 quarters, and 16 quarters means we've got 4 whole fraction bars shaded, because 16 divided by 4 is 4. So we have some fraction bars here, and we're going to use these to help us find fractions that are equivalent to 1/2. So we have 1/2 here because we have one part out of 2 parts shaded. How many quarters is equivalent to 1/2? Well, to find equivalent fractions, we can use multiplication. 2 times 2 is 4, and what we do to the denominator, we need to do to the numerator as well, and 1 times 2 is 2. So 1/2 is equivalent to 2 quarters, and we can see we've got 4 parts altogether, so that's a denominator of 4, and if we shade in 2 of those parts, so 2 quarters, we can see that we've shaded in the same as 1/2, so we can see that our fractions are equivalent. They have the same value. Now, 1/2 is equivalent to how many sixths? Well, we use multiplication or division to find equivalent fractions, and 2 times 3 is 6. What we do to the denominator, we need to do to the numerator as well. So 1 times 3 is 3, so 1/2 is equivalent to 3/6. We can see this fraction bar here is split into 6 pieces, so into sixths, and if we shade 3 of those sixths, we have 3/6, which we can see is the same as 1/2. Now, 1/2 is equivalent to how many eighths? Well, 2 times 4 is 8. What we do to the denominator, we do to the numerator as well, and 1 times 4 is 4. So here we have a fraction bar that's been split into 8 pieces, and if we shade 4 of those pieces, we have shaded the same as 1/2. 1/2 is equivalent to how many tenths? Well, you can probably see where we're going with this. 2 times 5 is 10, so do the same to the numerator. 1 times 5 is 5, so if we shade 5 of our tenths, we have a fraction that's equivalent to 1/2. It has the same value as 1/2. And now 1/2 is equivalent to how many twelfths? Well, 2 times 6 is 12, 1 times 6 is 6, so if we shade in 6 of our twelfths, we have the same as 1/2. We can use multiplication to find equivalent fractions, that is, to find fractions which have the same value. So first, 1/3 is equivalent to how many ninths? Well, 9 is in the 3 times table. 3 times 3 is 9, and when we're finding equivalent fractions, what we do to the denominator, we need to do to the numerator as well, and 1 times 3 is 3. So 1/3 is equivalent to 3/9. 3 is our missing numerator. Now, 3/5 is the same or equivalent to how many tenths? Well, 10 is in the 5 times table, and 5 times 2 is 10. What we do to the denominator, we do to the numerator as well, and 3 times 2 is 6. so that's our missing numerator. Now, 2/5 is equivalent to how many 20ths? 5 times 4 is 20, so to work out our missing numerator, we need to do 2 times 4, which is 8. Now for these next questions, it's the denominator that's missing, but we follow the same steps. 8 is in the 2 times table, 2 times 4 is 8, and here what we've done to the numerator, we need to do to the denominator. And 3 times 4 is 12, so 12 is our missing denominator. 2/3 is equivalent to 8/12. Now, 3/4 is equivalent to 9 over what? Well, 3 times 3 is 9, and what we do to the numerator, we need to do to the denominator. 4 times 3 is 12, so our missing denominator is 12. 3/4 has the same value as 9/12. And we can see what we're doing here with fraction bars. So 1/3 is equivalent to 3/9. We can see that if we shade in 3 of these ninths, we have the same amount in both fraction bars shaded. Now, 3/5, if we want to find an equivalent fraction with a denominator of 10, we can split our fraction bar into 10 pieces, and we can see that we need to shade 6 of those pieces so that the fraction bars have the same amounts shaded. So it's really important to understand 6/10 is not larger than 3/5. 6/10 is equal to 3/5. It has the same value because we can see here we have the same amount shaded. Now 2/5 is equivalent to 8/20 because the same amount is shaded. Now 2/3, we needed to work out what the denominator was. We knew that the numerator was 8, so if we have the same amount shaded and split what's shaded into 8 pieces, we will have 12 pieces in our fraction altogether. So that's 8/12. And 3/4, we knew that our numerator was 9, and if we split what's shaded blue into 9 pieces, we have 12 pieces in our fraction altogether, so the denominator is 12. So the important thing to understand here is that we always multiply the numerator and the denominator by the same number. Next, we'll work out how to find equivalent fractions by dividing. So we've seen that we can find equivalent fractions by multiplying the numerator and the denominator of a fraction by the same number. But here, we're going to use division to find equivalent fractions. So first, 6/9 is equivalent to how many thirds? Well, we can't use multiplication here because 3 is smaller than 9, but we can use division. 9 divided by 3 is 3. That's because 3 times 3 is 9. And just like when we were finding equivalent fractions by multiplying, what we do to the denominator, we need to do to the numerator as well. 6 divided by 3 is 2, because 2 times 3 is 6, so our missing numerator is 2. 6/9 is equivalent to 2/3. And what we've done here is called simplifying the fraction. So the fraction is still equivalent, it still has the same value, but it uses smaller numbers. Now, 4/12 is equivalent to how many thirds? Again, we need to use division. 12 divided by 4 is 3, because 3 times 4 is 12, and again, what we do to the denominator, we need to do to the numerator as well, and 4 divided by 4 is 1. So 4/12 is equivalent or the same as 1/3. Now we have 20 over 24, and we need to find an equivalent fraction which has a denominator of 6. 24 divided by 4 is 6, because 6 times 4 is 24, and again, what we do to the denominator, we need to do to the numerator as well. 20 divided by 4 is 5, So 20 over 24 is equivalent or has the same value as 5/6. Now here, it's the denominator that we need to find, but we follow the same steps. We can see, if we look at the numerators, 6 divided by 3 is 2, because 2 times 3 is 6, and here, what we've done to the numerator, we need to do to the denominator. 15 divided by 3 is 5, because 5 times 3 is 15, so 6/15 is equivalent to 2/5. Now here, we have 10 over 20, and we need to find an equivalent fraction with a numerator of 1. 10 divided by 10 is 1, because whenever you divide a number by itself, you always get 1 as your answer. And here, what we've done to the numerator, we need to do to the denominator as well. 20 divided by 10 is 2, so 10 over 20 is equivalent to 1/2, or 1 over 2. Now it's important to understand that though these equivalent fractions use smaller numbers, they're not smaller. With equivalent fractions, we always get fractions which are the same size. And we can see that if we have 6/9, or 6 parts out of 9 shaded, that's equivalent to having 2 parts out of 3, or 2/3 shaded. We can see also that 4/12, so 4 parts out of 12, is equivalent to 1/3. The same amount of both fraction bars is coloured in blue. Now, 20 over 24 is equivalent to 5/6. 6/15 is equivalent to 2/5. And 10 over 20, or 10/20 is equivalent to 1/2. So we've used, in the previous video, multiplication, and in this video, division, to find equivalent fractions. But it's really important to understand that those are the only operations we can use. We can't use addition or subtraction when we're finding equivalent fractions. We can only use multiplication or division. For these questions, we need to find a fraction of a number. Now we know how to find a unit fraction of a number, so a fraction with a numerator of 1. If the numerator is 1, you can find a fraction of a number just by dividing by the denominator. So if we were finding 1/5, we would just divide by 5. Finding 1/6, we would just divide by 6. And finding 1/8, we would just divide by 8. But in these fractions, the numerator is larger than 1. That means that we can still start by dividing by the denominator, but then we need to take our answer and multiply by the numerator. The way I remember this is divide denominator times top. So first we have 2/5 of 30. We can start by dividing by the denominator, so dividing 30 by 5, that gives us 6, and then we can take that 6 and multiply it by the numerator, so times top, and 6 times 2 is 12, so that's our answer. Now we need to find 5/6 of 24, so we can start by dividing 24 by 6, so divide denominator. That gives us 4, because 4 times 6 is 24. But then we need to take that 4 and times top, so multiply by the numerator. 4 times 5 is 20, so that's our answer. And finally, we have 3/8 of 24. So 24 divided by 8, so divided by the denominator, is 3, because 3 times 8 is 24, but then we need to take that 3 and multiply it by the numerator, so times top, and 3 times 3 is 9, so that's our answer. So let's think back to this first question. We needed to find 2/5 of 30. So for 2/5, we can show a fraction bar divided into 5 parts, and we're finding 2/5, so we can colour in 2 of those parts. Now the number we were finding 2/5 of is 30, and if we share out 30 counters between our fifths, you can see that we have 6 counters in each of our fifths, and that's why we divided by the denominator. So 30 divided by 5 told us there were 6 counters in each fifth, but we were finding 2/5, so we needed to multiply that 6 by 2 to get 12. And if you look, we have a total of 12 counters in the shaded area of our fraction bar, so that's our answer. Then we needed to find 5/6 of 24. So to show 5/6, we can split our fraction bar into 6 parts, and we find 5/6, so we can colour in 5 of those 6 pieces. If we share out 24 counters between the sixths, we can see that we have 4 counters in each of our sixths, and that's why we did 24 divided by 6 to get 4. But that's 1/6, and we needed to find 5/6, so we multiplied that 4 by 5 to get 20. And you can see that we have 4 in each of our sixths, but because we have 5/6, we have 4, 8, 12, 16, 20 counters in our shaded section, so our answer is 20. Finally, we had to find 3/8 of 24, so we can split our fraction bar into eighths, and we're finding 3/8. Now, if we share out 24 counters, then you can see that we have 3 counters in each of our eighths, and that's why we divided 24 by 8 to get 3. But we have 3/8, so we needed to multiply by 3 to get our answer of 9. And you can see that we have a total of 9 counters in the shaded area of our fraction. So here we've got some missing number problems for finding a fraction of a number. Now we know that normally to find a fraction of a number, we divide by the denominator and multiply by the numerator. But here, because we know our answer, but we don't know the total quantity, we've basically got a missing number problem, so we need to do the opposite or use the inverse. We need to divide by the numerator and then multiply by the denominator. So 2/5 of what equals 10? We can do 10 divided by 2, so divide by the numerator to get 5. Then we can take that 5 and multiply by the denominator to get 25 as our total quantity. And that makes sense, because 25 divided by 5 is 5, and then 5 times 2 is equal to 10. So now 5/6 of what equals 15? Again, we've got a missing number problem, so rather than dividing by the denominator, we need to divide by the numerator, and 15 divided by 5 is 3. Then we can take that 3 and multiply it by the denominator. That gives us 18 as our total quantity, and we can check that this works because 18 divided by 6 is 3, and then 3 times 5 is 15. Finally, 3/5 of what equals 15? It's a missing number problem, so instead of divide denominator, we can divide by the numerator, and 15 divided by 3 is 5. So then we can take that 5 and multiply by the denominator to give us our total quantity of 25. And again, we can check that it works. 25 divided by 5 is 5, times 3 is 15. So let's look back to this first question and think about what we were doing. We knew that 2/5 of something was 10, so we can show a fraction bar split into fifths, and we have 2/5. Now we know that 10 is in those 2/5, So what we did is divide 10 by 2. That gave us 5, and that told us that there were 5 counters in each of our fifths. But if there are 5 counters in each of our fifths, there must be 5 counters in these other fifths as well. So we multiplied 5 by 5 to get 25, because there are 5 fifths in our whole quantity, and if you count how many counters we now have altogether, we have 25. Then we knew that 5 sixths of something was 15. So we can show a fraction bar split into sixths, and we have 5 sixths. We know that 15 is in those 5 sixths. So what we did is divide 15 by 5, and then we knew that there must be 3 counters in each sixth. So there are 3 counters in this sixth as well. What we did was we took the 3 and then we multiplied by 6, because there are 3 counters in each of our 6 sixths. That gave us 18 as our total quantity. Finally, we knew that 3 fifths of something was 15. We can show a fraction bar with 3 fifths, and we know that 15 counters need to be shared across those 3 fifths. So we divided 15 by 3 so that we knew that there were 5 counters in each of our fifths. But if there are 5 counters in each fifth, there must be 5 counters in these other fifths as well. So we multiplied by 5 to get 25 as our total quantity.